Hello and welcome back once again. We're going to be moving on from multiplication today, but before we do, let's look at our thinking question from the last lesson. How does an understanding of the traditional algorithm help you? Well, I think that it helps me in the sense that I will remember the step of always putting my placeholder 0 if I'm multiplying by the tens or the hundreds, or then if I even go up into 4 and 5 digit numbers, I'm just going to keep adding placeholder zeros because I know what I'm doing. I know that I'm not actually multiplying by single digits, I'm actually multiplying by much larger numbers. And in order to represent that in my partial product, I have to put the placeholder zeros. So that's how it helps me, but it may help you in different ways. Today we're going to be moving on to multi-digit division. So we just did multi-digit multiplication and now we're going to division. And just like with multiplication, this lesson is in two parts. And this is part one, obviously. And you will be learning the partial quotient algorithm or strategy. And then in part two, you're going to be learning the standard algorithm, which you won't really understand unless you understand partial quotient. So it's just like partial product, then learning the standard traditional algorithm for multiplication. That helped you to understand how to do it because you knew the partial product. The same thing is going to hopefully happen with division. The only materials you need are paper and pencil. And in order to know exactly what we're talking about, we do need to know a little bit of division vocabulary. And quotient means the answer to a division problem. So where product is the answer to a multiplication problem, quotient is the answer to a division problem. So now the name partial quotient strategy probably makes a little bit more sense. You probably know, okay, we're going to be finding parts of the answer and then we're going to probably have to add them together like we did with multiplication. And you're absolutely right about that. So then we have two other vocabulary words that are really easy to mix up in division. In fact, I still get them mixed up sometimes. So we're going to go over them now and we're going to try to use them in this video to help you to know what they are and remember what they are. So a divisor and a dividend. A divisor is the number you are dividing by, and a dividend is the number that is being divided. So if I say 24 divided by 6, that's really saying 24 going into groups of 6. So I'm dividing the 24. So that's the dividend. The dividend is the number that is being divided. The 24 is being divided into groups. The divisor is the number you're dividing by. So if I said 24 divided by 6, the divisor is going to be 6 because that's going to be the number of groups or the number that is going in each group that I'm dividing by. And then the answer, which would be 4, would be your quotient. So the first problem we're going to look at is 567 divided by 9. So what that is really saying is we have 567 of something. And we're going to be dividing that into groups of 9 and seeing how many groups, equal groups of 9 we can get. And the way we're going to write that in order to be able to use partial quotient is like this. This is our division symbol. So this is saying 567 divided by 9. You're going to put your dividend on the inside and your divisor on the outside because this is the whole and you're dividing it into 9 groups. In order to use partial quotient, we have to make a line down the side here. And that's to help me keep my numbers separated. So the first thing I'm going to ask is, remembering that this is the number 567, I'm going to ask myself, how many 9s do I think there could be in 567 without going over? Well, I know that 9 times 10 is 90. 90 definitely fits in there, so I'll do that. So I'm going to put a 10 over here. That tells me that I have already tried 10. And then I'm going to put a 90 over here because 9 groups of 10 is 90. So far I know that I can get at least 10 groups, 10 equal groups from 567. When we have 10 groups of 9, that's 90. So far I have separated 90 out of the 567. So I have to subtract that from my dividend so far. So I have 477 left. Now I know that I can get at least another 10 groups of 9, but I think I could probably even get more than that. I'm going to try 20 groups of 9. So I'm going to put a 20 over here. So I'm taking out 20 more groups of 9. Now if 10 groups of 9 was 90, 20 groups of 9 was going to be 180. Now I'm going to subtract 180 because now I've taken 180 more out that I've split up. I have 297 left. I can definitely still fit another 20 because I know that 20 groups is 180. There's definitely 180 left, so I'm going to do another 20 groups. And that's going to be subtracting another 180. Okay, I have 117 left. I can't fit 20 more groups, but I can fit 9. I can fit 10, I'm sorry. So 10 more groups, that's 90. And I'm actually going to bring this over here. So 117 minus 90. So this is just a continuation of that. I just didn't have any more room. It's 27. How many 9s can go into 27? Well, I know 9 times 3 is 27. So that's 3 more groups. I'm going to subtract 27. And that's nothing left. So I just split 567 into this many groups of 9 evenly, and there aren't any leftovers. But these are just partial quotients. They're just parts of my answer. So I have to add those together, and then I have my answer. So let's see. 0, 0, 0, 0, 3, that's going to equal 3. And then 1, 2, 3, 4, 5, 6. The answer is going to be 63. And where I'm going to write my answer, I'm going to line it up with the same place value. So I'm not going to write it over here where the hundreds place value is. I'm going to write it starting in the tens place value because it's 63. So there are a lot of steps, it seems, in partial quotient, but it's really just guessing and checking to see how many times you can get the dividend to be split evenly by the divisor. So we are going to do some more practice problems with these, and then this will help you in the next lesson to find a shorter shortcut that will get you the answer a lot faster, but you'll be able to understand why you got the answer faster. Now, one thing to take note of is that it is going to be difficult for us to do these problems together because everybody's going to use different partial quotients that they're more familiar with. I'm really familiar with my 10s, and so I find it really easy to take out groups of 10s and 20, but other people might be more familiar with other partial quotients and be more comfortable with those, and so everybody's going to use slightly different numbers. The most important thing is that we get the same answer though. We'll set this one up together, and then I'm going to let you solve it on your own because, like I said, it's going to be difficult to do it together because everybody is more comfortable with different partial quotients. So the problem is 256 divided by 3. So what we're really asking is how many times can 256 be evenly split into groups of 3? We're going to set it up like this. You're going to pause your video and draw this along with the line down the side so that you can keep track of your partial quotients. Pause your video and do that now. All right, so now that you have written it out, you're going to ask yourself how many times 3 can go into 256 without going over. And then you're going to put your partial quotients as you find them along the side. Don't forget to subtract however many are in that number of groups. So if I say 20, I know that in 20 groups of 3, that's 60, so I have to subtract 60 because I've put 60 in groups so far. All right, so pause your video and solve that now. No matter which partial quotients you chose, you probably found that you ended up with 1 at the end. You should have found that you ended up with 1. If not, then something went a little bit wrong with your math in here. That's because we can't make any more equal groups of 3. When we only have 1 left, that would be a group of 1, and that's not the same as being a group of 3. That is called our remainder. That is what's left over. So we're still going to add together our partial quotients. So I have 85, remainder 1. So I'm going to write that up here, again, lining it up with the place values, and then you put an R for remainder 1. Remainder 1. Go ahead and try this one on your own. 4,115 divided by 7. You're going to set it up and solve it on your own. Go ahead and do that now. The answer is 587 remainder 6. You should have ended up with 6 at the bottom, and you can't make another even group of 7, so that's just going to have to be the remainder. And if you started with hundreds, that's great, because that was a big number, and it would have taken a really long time if you kept subtracting by tens. So I subtracted first by 100, a group of 100, and then 400 groups of 7, and then 80 groups of 7, and then 7 groups of 7. And that got me my answer, 587, remainder 6. We're going to try another one. Pause the video and solve this one now. The answer to this problem is 932, remainder 2, because you can't make another equal group of 4 when you only have 2 left. And again, I started with the hundreds, because I knew that it was going to take a very long time if I tried to take away groups of 10 or 10 groups of 4 at a time. And another practice problem. So pause the video and solve this one now. The answer to this problem is 754, remainder 3. The more familiar you are with your multiplication problems, the faster you're going to be able to come up with partial quotients that get you really close to your final answer. So I would really recommend practicing multiplication if you want to get better at this. We're going to try a word problem now. Julian's family won the lottery. After taxes are taken out, they have won a total of $24,762. The family decides to split the money evenly between everyone. There are a total of 5 family members. How much money will they each get? So you're going to pause the video, write out the division problem that's going to represent this word problem, and then you're going to use the partial quotient equation or algorithm to find the answer. Pause the video and do that now. Okay, so our division problem is 24,763 divided by 5. So then I put that into the equation up here, and then I solved it using the partial quotients and added my partial quotients together, and I got $4,952 each. And then there's $3 left over that nobody's going to get because it can't be split evenly between 5 people. Let's try one more word problem. Your company is bagging 2,000 pounds of potatoes. Each bag contains 8 pounds of potatoes. How many full bags will you have by the end? So you're putting potatoes into a bag. Each bag gets 8 pounds. You have 2,000 pounds to bag, so how many bags do you need? How many full bags will you have? You're going to pause the video and solve that now. This one was fairly simple because there is no remainder. The 2,000 pounds will evenly split between 250 bags. So there will be 250 bags when you are finished bagging those potatoes. Great work today on the partial quotients, and in the next lesson you'll get to take a crack at the standard algorithm that you'll be able to understand better because you know the partial quotient algorithm. So our thinking question is, how do you use multiplication to help you with solving division problems? So we're kind of combining multiplication and division into one thinking question, but I know you can think about it and that you will come up with a great answer before the next video, before the next lesson. Bye!